People often ask me, where do I get my dad jokes from? And I tell them that I have a database. Shout out to you all.
Come on now, dog. Come on, man.
Hey Stats Cats, shout out to you all. It's Mr. C here, and in this video I'm going to break down the section 1.3 guided note packet that I recently built. And the format of this video is going to be a little bit different than the previous two. I realize they're getting a little lengthy, so what I'm deciding to do is just try this format out where I build the notes beforehand and I just kind of go through my rationale and also show you some things that I feel might be helpful for you. Okay, so we are currently in section 1.3 of the Triola Stats 14th edition. It's elementary statistics by Mario Triola, that is. And this section is on collecting sample data. And this is the last section of the chapter 1 in that textbook. So I figured to start things out for the guided note packet, it's probably a good time to do like a quick summary of, like where we've come from. And obviously this is where we're heading to, collecting sample data. I find that, there are definitely some points throughout the semester where quick summaries are absolutely essential because you can really get lost in the details and not really see the forest through the trees, so to say. So this doesn't have to be anything, that takes too long. What I have here is some smart art from Microsoft Word that I like to do whenever there's like some sort of process happening. And in this case, our process is learning, and in particular, learning the content of chapter 1. So section 1.1 was on statistical and critical thinking. So something that I'm thinking about asking the students about is, what were the major concepts of this section? And I'm hoping that they'll mention some of our key items from that video, one of them being the flow chart on statistical thinking. And of course, if they don't offer that up, then I'll remind them about it. And then also, too, types of data. And what I'm doing here with this entire thing is I'm trying to paint like a 3,000-foot view of, where we're headed and just why these are such foundational skills for moving forward. And of course, as with any math class, it's all interrelated. And that's a good thing, and it can be a bad thing because you might not know like which direction to take based on your current position in the course. All right. So for types of data, I'm hoping that they recall, like nominal data, ratio data, interval data, things like that. So you need all this stuff because when it comes down to collecting sample data, and then doing some statistics with it, depending on the type of data you collect, you're going to select the corresponding statistical method, okay? And how the data is collected is extremely important. So this takes us to the next subsection of design of experiments. And it says here, when analyzing sample data, it is very important to use an appropriate method for collecting it. All right, this is because, and this is something that I wanted to emphasize, of course, in my emphasis boxes. If sample data are not collected in an appropriate way, the data may be useless, misleading, or both. And as I was typing this out, I couldn't help but think about a personal story that hits home for me regarding my wife, Mrs. C. It says here, let's drive the point home with the personal story of Mrs. C's. And I got her permission to do this, so she actually helped me identify some things that are relative to this because although we've, been down a long road of trying different medical things out, some of it is still kind of foggy to what exactly she's experiencing. So She is, well, I'm going to call her a survivor of thoracic outlet syndrome, which, according to her, is something that happens when your spine grows extra vertebrae. And why I was thinking about this is because with when it comes to medicine, data collecting and data, of course, is extremely important. All right, and I'm something that I'm learning out of a book that I'm reading right now is that not in the very far past, um, things that were done medically were really just kind of based on intuition, or you could think of it as woo woo or like witch doctor stuff where it didn't really make much sense, but sometimes it worked, sometimes it didn't. And you'd be surprised that when medicine was first being practiced, data wasn't being collected. All right, there might have not even been some math that we could use to even analyze that data. So people just applied procedures based on anecdotal or uncle doodle um, information, and at some point they just kind of hoped and prayed for the best. So, for example, one thing that I've learned from this book is that they used to bleed George Washington when he came down from with a sickness, and they did some other things with him too, and it sounded extremely torturous. And he obviously, well, not obviously, but shortly after they were doing all these medical procedures, George Washington passed away, and they really couldn't determine if you know doing the procedure accelerated his death or slowed it down. Okay, so nowadays, when we do medical treatments, they're based on some really well studied studies, and it's important to do those sorts of studies, which, the design of the study is based on the data you're collecting and your method for collecting it. So, anyway, to make a long story longer, I have a diagram here that I'm going to be pointing out to my students. In this dash line right here is the extra cervical rib, I believe. And then I have a QR code that takes us to a website. This one here, Radiology Masterclass. And after doing some searching around, I really like this because it's somewhat interactive. So you can ask students, it could be a small activity depending on time. You can ask students to figure out where in the x-ray the extra rib is. And I really like this because a lot of my students are majoring in some sort of medical discipline, whether it's x-ray technology or sonography or even a medical doctor. So I figured this would be kind of a fun little interactive for them. Here's another one where you just hover over the picture and you can see where the extra rib is. And I'm going to hit hard on why it's important to, study these sorts of things and, doing it right so that, you can alleviate the symptoms that the patient is undergoing and hopefully cure them, if that's even possible. All right. So now on this page, I'm just kind of phasing into the methods of collecting sample data. This is something we're going to be filling out together. A sample should have the same characteristics as the population. Okay, because if it doesn't, then it's going to be harder to infer that your statistics describe the actual population parameters. Okay, you might be able to, but in my opinion, it's going to be a hard sell. So to best address this, most statisticians use various methods of random sampling, and I thought that it might be a great idea to pause and ask the students why sampling in a random way might be important. And hopefully, if they understand the question, hopefully somebody says something about bias, because that is something that, you know, all statisticians try to avoid, to the best of their ability. So the best way to make sure that your data is as pure as possible is to do a simple random sample or a simple random survey, or simply put, a random sample, which is defined as follows. Any group of n individuals is equally likely to be chosen as any other group of n individuals. And there are some pros and cons to this. I would say the pros definitely outweigh the cons. But This QR code takes us to a chat that I created with Claude.ai, and you'll notice that in this section I'll be leveraging AI a lot, and that's because it can create simulations really quick, and I think they're quite effective and give like another element of interactivity with students, myself, and the notes. So I'll show you the start of that. All right, so my initial prompt, let me zoom in a little bit for you guys. My initial prompt was, hello, can you give me an example of a simple random sample along with a visual example regarding social media that would appeal to first or second year college students? So there might be some redundancy in this. This is why I'm a math major, not an English major. I'm just kidding. All right, so as AI normally does, it gives you some extra game here. Simple random sample means every individual in the population has an equal chance of being selected. It removes bias by making the selection purely random, like drawing names from a hat. And I asked it, to give visual examples, and what it actually did was created like an interactive simulation. Here's the plot line here. Instagram wants to survey 5 students out of 20 about screen time. And in this simulation, they are doing their best to replicate simple random sampling. Of course, I'm not really sure if anything is ever truly random, especially when the thing that you're doing has been programmed by computer scientists. Okay, but that's neither here nor there. What's really cool about this is that you can show them the 5 students that are being randomly selected, and you can generate more and more random selections of 5 students. Zoom out just a tad bit. So right here it says draw a new random sample. And the thing that you want to show students is that there's no really overarching pattern to how these students are selected. And that's the idea of a simple random sample. All right, there's a little bit of context here. This sample, Alex, Riley, Quinn, Isla, and Brianna, each of the 20 students had a 1 in 20 or 5% chance of selection. That's what it means to make it a simple random sampling. All right, and the names change according to the new draw of people. All right, then a few key takeaways, which I think is really helpful for students, and they can always come back to this when we're finished with class and move on to other material. And this will be for the next part of the notes, so I'm going to take us back to Word. So I do want to show them how to generate random numbers on the graphing calculator, which I have instructions for that here. I'm going to use a TI-84 Plus graphing calculator in my class for my demos. So I have the syntax here: hit math, arrow over the probability, and then select option 5, and then type in the range of numbers you want to select from, as well as how many random numbers you want. And key thing here, each value needs to be separated by a comma. So the example I'm going to have them work on is generate 5 random numbers between 1 and 20 inclusive, and I'm going to refer them back to this classroom and maybe use these student numbers here. All right, so for example, if their graphing calculator generates the numbers 6, 7, if the graphing calculator generates 6 and 7, 10, 14, and 18, then this would be their selection of 5 students. So pretty straightforward there. So now we move on to the crowning jewel of the section, collecting sample data. It says here, and this is kind of a proviso, no single technique. Actually, I should change that. Okay, I'm in the box, like man in the box. Okay, I'll put there is no single technique that works for every scenario. And what I'm referring to is your choice of how you collect sample data Uh, it kind of depends on what kind of data you have and what you're looking to investigate. All right. Um, so it goes further into this. This could be due to practical restraints. So, for example, it'd be difficult to randomly sample um, 1 million U.S. citizens um, because a lot of people live very far apart, and it could get really costly and time consuming. And this is why we have other sampling methods, is to cut down on time and cost, but still retain um, an element of pureness as best as possible. All right. But usually there's a level of compromise that has to be taken into account. All right. So this could be due to practical restraints, the need to ensure fair representation, handling hard to reach populations, etc. I'm going to widen this just so that I can save on some space. Okay, so in addition to random sampling, there are other forms of sampling that involve a chance process. So we're trying to keep an element of randomness as best as possible with these to make sure that the data is pure. Okay, so here are the other sampling methods: systematic, convenience, stratified, and cluster sampling. Um, as I was contemplating how I want to present these sampling methods, I thought back to my old teaching days where we have like a four-corner diagram. And so you'll see these boxes that I've created, and that's basically just done by making a table. So what you do for that is you go to Insert, Table, and you just select, the size that you want, or the size of your table, how many cells you want in it. And when you get comfortable enough with it, you can get fancy and, create some column headings within each one of the rows. And now that I'm looking at it, the font isn't consistent, but I'll fix that. Okay. Yeah, so here are the four corners: definition, and this is the definition from our textbook. A visual, which I grabbed a couple of screenshots from our textbook for this. This is systematic sampling, the sampling method in which we select every starting point and then select every kth element in the population. So as you can see here, we have a bunch of cars lined up, and let's say that we wanted to choose every third car. Okay. And then I have a real life scenario where this would be applied. In a manufacturing plant with products moving along the conveyor belt, every 10th product could be systematically sampled for quality control inspection. And then I thought it might be cool to just write down some pros and cons to this method. And then after that, it says, let's go back to the QR code from the previous page to see a simulation of systematic sampling. So this is where I'm going to have us go back to Claude, and I had Claude create an example of systematic sampling. And here it says Instagram surveys 5 students from 20 by picking a random start, then selecting every 4th person. All right. And they get that by doing 20 divided by 5 equals 4. Now, who you start with is randomly selected. All right. So you want to be aware of that. And if you look at this button right here, new random start, you can see that the first person that's being chosen is being selected at random, but then the next person chosen is 4 students away from that first one. All right, so if we start with Brianna, then we count from left to right: 1, 2, 3, 4. Felix would be the next person selected. Then 1, 2, 3, 4 again would mean Jordan selected. And this changes, of course, depending on who you're starting with. Okay? So that's the idea behind systematic. All right, and then convenience sampling, as the name kind of implies, it's a sampling method in which we simply use data that are very easy to get. And I couldn't help but think of the solicitors at Target. This one's for DirecTV, but my Target has AT&T as these guys, which looks like they might be kind of in the same company. But if you've ever been to Target during the midday and walk past like the electronics area, sometimes there's a vendor for AT&T, and they try to you know, rope you in by asking some questions, which is basically like data collection. So, like a common question would be, who's your data service provider? Or do you like the cable service that you're receiving right now? That's all convenience sampling because you're a really easy target to get data from. All right, let me change the font with that. So I put a picture, and I'm hoping that this resonates with my students. Okay, so I'm going to be going back to Claude, and here's the new scenario. Okay, Instagram surveys students by asking whoever is easiest to reach, e.g., so for example, only students that are currently online, the others are never asked. All right, so I asked Claude to give me a simulation of convenience sampling. And so the scenario here is, let's say Instagram sends out a survey to my class of 20 students, but they're only able to send it out if the student is online. Okay. Um, and you can see that there are some really faded boxes, and these faded boxes represent students that are not online. Whereas the non-faded boxes, including those that are kind of highlighted here, those represent people that are online. So Instagram is only going to be able to give their survey if, some of my students are online. All right, which of course happens. Okay, not the biggest deal breaker. So that's kind of unfair because there might be some students that are not online at the time, and they never would have a chance to participate in that survey. So as you can see, there's some downsides to this, and can create other clusters of students or other sets of students that are online as well as selected. Now, if you look here, this is kind of cool, a little meter bar. It tells you how many students had zero chance of selection. And as you roll through different scenarios, you can see that the percents fluctuate. And obviously, that's going to throw off your data, all right, in a lot of cases. In some cases, it's fine. And what I like about what Claude's doing here is that it kind of gives a quick summary, a side-by-side walkthrough. All right, so far we've done simple random. Everyone has an equal chance. Random element is every pick. Systematic, everyone has an equal chance with this as well. And it has a starting point, and you select every kth element. Convenience, only whoever is easy to reach. And there's no random element to that. Okay, so think of the AT&T people. They're going to ask whoever walks by them. All right, but there are some people in the store that never go in that area, so they don't have a chance of being selected. All right, and from there on out, it's pretty much copy and paste. So I have a four-corner chart for stratified sampling, definition, a visual, so the different generations is what I was thinking about, a real-life example, pros and cons, and going back to Claude, it gives a simulation of stratified sampling, which I really like. So with stratified sampling, you group people into groups where each member has a certain type of characteristic. So maybe I have 5 students that are freshmen in my class, 5 students that are sophomores, 5 that are juniors, and so on and so forth. Then I can split them up into these 4 groups. And then within each group, I do a random selection of students. Now, you got to be careful with stratified sampling and the very last one, which is cluster sampling, because they seem almost identical, but of course our job as professors is to include nuance to help them differentiate between the two. But just from a notes creation perspective, I stuck with the 4-corner thing: definition, visual, real life example, and then pros and cons. And then I had a final simulation by Claude given. And here you can see the difference between cluster and stratified sampling. So it says here, Instagram divides 20 students across 4 halls of residence. 2 halls are picked at random, then every student in those halls is surveyed. So it kind of seems like it's stratified, but the major difference is that the only people that are going to be surveyed are those that come from the clusters. And typically speaking, everybody in the selected clusters is going to be sampled. So what is the major difference here is that these people that are in Oak Hall and Pine Hall, they don't have a chance of being selected because once we select our 2 clusters, which can be chosen at random, as you see here, it's only these people that are going to be surveyed. So we might miss some information from those that could have been surveyed from Maple Hall that's important information. All right. So a helpful thing about stratified is that you separate students into groups according to a certain characteristic, and you pick people from each group. Whereas with cluster, you might divide the students up into groups, but then you randomly choose a finite number of those groups and sample everybody in those groups. So there are going to be some people from the other groups that are left out. And then finally, there's a side-by-side comparison of the 5 methods: simple, random, systematic, convenient, stratified, and clustered. So like I said, I'm going to be sharing this QR code with my students so they can play around with it. And I think the simulation idea really drives home a way to get interactive with them, as well as really drive home the different nuances between sampling methods. So to start closing things out, I have a page of examples. We're going to go through all these together. And these examples were taken from the textbook. They're part of the exercises. So I just basically copied and pasted. And one thing that I did here is I made sure to include more examples than there are sampling methods. That way they don't use the process of elimination to try and guess some of these. Okay, so I'll take them through each one of these, and there'll be some small discussion after our problems are answered. And then the last item is I'm calling this putting you up on some game. So there's some other information that's really helpful for them to know that I feel doesn't necessarily warrant going into as deep as like the level of creating a simulation. So I might have the students read this on their own depending on time. And I'm hoping to build in at least a few minutes to kind of skim through this and let them know that we're not going to necessarily go into the fine details of it, but it is something that you want to be aware of. So like different types of error to know, sampling error, sampling bias, and that really drives home the point of introducing an element of randomness so as to be fair to everybody and to get as pure of a collection of people or sample as possible, and it'll make your statistics better. And some other sampling problems. So of course, a biased sample, voluntary response things, maybe missing data, or if you're blending the sampling methods together, which you can, there's this idea of confounding. Okay, sample size too small. Of course, the more sample data you have, the better, but in a lot of cases, you can't get a lot of sample data. So for example, doctors studying a very rare type of cancer, you only have the data that's available to you. People not responding to things. So for instance, maybe a survey asks, couples in America what their net income is per month. and they might not want that information out there. Okay. It's self-interest. All right, self-funded studies. So maybe there's like a vegetable company that is at Costco, and they're giving out free samples, and maybe it's free samples of tater tots, and one of the questions on their survey is, do you like tater tots, yes or no? Okay, so um, that's something that we want to avoid if we want to come up with genuine statistics. And that's really it for this section of notes. Of course, if you have any questions about anything that I've included, or if you want me to send me this file to you, I'll be more than happy to, as well as the links to any of the QR codes that take you to websites. And yeah, hopefully you like the format of this video. Feel free to leave some feedback on this in the comment section, and don't forget to smash that like button and subscribe. And until next time, I'll see you later. Have a great rest of your Sunday, Stat Cats, and thanks for watching.
Come on now, dog. Come on, man.
But yeah, today